Good evening, everybody. Today we are going to be learning about multiplying and dividing rational numbers. To begin with, I would like you to head your notes with the I can statement of the lesson. I can multiply and divide rational numbers. So while you are writing down the objective of the lesson, or the I can statement, I can multiply and divide rational numbers, I'm going to talk to you and just review a couple of things with you. Notice I don't have positive and negative rational numbers listed in the I can statement, and that is because positive and negative numbers are included in rational numbers. So when I simply say rational numbers, I am including all positive and negative integers, whole numbers, natural numbers. I'm also including all decimals that either repeat or end, and I'm including everything that can be written as a fraction. Now what I would like to do is I would like to take some time and review over the rules that you learned from Mr. Dudek's video. If you remember, and I'm going to abbreviate, I'm not going to write everything in words, but when you multiply a positive times a positive, you get a positive. You should be writing this as well. And those of my students, you know that what I write, you write, because I know it. I'm writing it for you. I'm not writing it for me. A negative times a negative is also a positive. Well, if you have a positive times a negative, what happens? It is going to be a negative. Well, the same rules apply for division. A negative divided by a negative is a positive. A positive divided by a positive is still a positive. But when you have only one lonely negative number, it doesn't have another negative one to make it happy or positive, so guess what? It's still unhappy. Okay, so that's a quick review of our integer rules for multiplying and dividing. Well, today we are going to apply those rules to rational numbers. So let's look at a couple examples. Just remember that when you multiply fractions, remember you will multiply the numerators and then you will multiply the denominators. So in this case, we are going to multiply 2 times 3. Notice the little multiplication symbol. You get 6 over 3 times 4 is 12. And always remember the unwritten rule: reduce, simplify if needed. You will see that the greatest common factor between 6 and 12 is 6. 6 goes into 6 once, and 6 goes into 12 2 times. So that means that 2/3 times 3/4 is 1/2. Again, you should be writing down these examples, as we will be checking them in class tomorrow. The next example is going to be the same process, except for notice here now you have a negative. So if I were you, I would just take this negative that's right there in the middle and I would just rewrite it up at the top and then kind of get rid of it right there, because it's really negative 5 times 3. Well, what is negative 5 times 3? Negative 15. Then we multiply 12 times 8. Well, if you're not sure right off the top of your head what 12 times 8 is, please do not use a calculator. Just simply write it like this and then multiply it out. 2 times 8 is 16. 8 times 1 is 8, plus 1 is 9. So you get 96. Well, then I want you to think, well, what goes into both negative 15 and 96? And the greatest common factor of both 15 and 96 is 3. 3 goes into negative 15 negative 5 times, and 3 goes into 96 32 times. That is your simplified answer. And for those of you who may remember, if you want to, when you are multiplying rational numbers, if you see something where you can cross cancel, we do not cross multiply, but if you can cross cancel, which means if you have any numerator have anything in common with any denominator, you can cancel it. Well, 5 has nothing in common with 12, but 3 has something in common with 12. Well, 3 goes into 3 once, 3 goes into 12 4 times. So now what we're multiplying is negative 5 over 4 times 1 over 8. All I did was rewrite the problem with simplified answers. So now I'm going to multiply my numerators. Negative 5 times 1 is negative 5 over 4 times 8 is 32. Notice I have the same answer. But notice here I am simply simplifying smaller numbers, where up here I'm simplifying a little bit bigger numbers. No big deal. Let's go to the next page. On this next page, you will just see examples of fractions multiplied by mixed numbers. Again, you are simply going to multiply numerators. But here, there's an additional step. You need to ensure that both fractions are just that. Fractions, either proper fractions or improper. So we need to take a step and we need to multiply that 2.5, the denominator times the whole number. Add that numerator to make it an improper fraction. 2 times 2 is 4, plus 1 is 5. So that means we have 5 over, keep the denominator of 2. Well, if you notice, you can cross cancel. You should see, wow, those 5s have something in common. They both have a 5 in common. Cross them off, put a 1. You should also notice, oh, the 2 and the 12 have something in common. 2 goes into 2 once, 2 goes into 12 6 times. Please make sure you rewrite the reduced fractions, as that will help you not make simple mistakes. 6 times 1 is 6 over 1 times 1 is 1, which is then simply 6. Now, if you notice, we have mixed numbers, but both being negative. Like I said in class, anytime you have your signs, I would take care of your signs in the beginning of the problem. A negative times a negative is what? You should be thinking in your head. All right, you should be thinking a positive. So I just put that right there just so I remember I dealt with my signs, and then I kind of get rid of them. Then I need to change my mixed numbers into fractions. So 6 times 1 is 6, plus 5 is 11. So I end up with 11 over 6 times 8 times 4 is 32, plus 1 is 33 over 8. Now remember, your answer is going to be positive. I do notice that I have something in common between the 6 and the 33, and that is 3. 3 goes into 6 2 times, 3 goes into 33 11 times. Now I multiply 11 times 11, and I get, that is a perfect square that you should know, should be 121 over 2 times 8 is 16. And if you notice, I made a mistake of what I even wanted to do, because if you notice, it took me a second to realize what I was multiplying here. What I told you up earlier is I like to rewrite what my reduced problem is. It makes it a little bit easier to then know what I'm multiplying. So I get 121 over 16. I want you to take a minute and see if you notice anything that goes into both 121 and 16. Okay, hopefully you realize if you're not really sure and you're like, goodness, I have no idea how to reduce that, especially without a calculator. Well, you definitely know that 16 times 10 is 160, which is too much, okay, because obviously this is 121. Well, then let's reduce that a little bit and let's take, 16 times maybe 7. And let's look at that. 6 times 7, we've got 42. 7 times 1 is 7, plus 4 is 11. I have 112. Wow, that's pretty close. So we know that 16 goes into 121 7 whole times, with how many left over? Well, we need 8 to get to 120, one more. So that gives us 9 over 16. And again, a negative times a negative is my positive answer, so I get positive 7 and 9/16. Now I would like you to take some time and we are going to do division. Let me put these division symbols in here because my computer program would not do that. All right, so let's remember that to divide a fraction, we multiply by its multiplicative inverse or multiplicative, depending on how you say that. I like saying the multiplicative inverse, which you also know as the reciprocal. So remember, we change the division to multiplication, we flip the second fraction or take the reciprocal. So we have 4/5 times 10 over 3, and then you remember your multiplication rules. On this one, I am simply going to cross cancel, if I can color change. 5 goes into 5 once, 5 goes into 10 twice. So I have 4 over 1 times 2 over 3. I multiply straight across. 4 times 2 is 8, over 1 times 3 is 3. 3 goes into 8 2 times, with 2 left over, out of 3. Now we're going to do the same thing, except for I have subtraction. And I also, remember, need to make my 3 as a fraction. Remember, all whole numbers go over 1. So this is really negative 5 over 6 times 1 over 3. Well, think to yourself, I have a negative times a positive, so my answer is going to be what? Yep, you should be thinking it's negative. So now I'm going to get rid of that negative sign, and then I'm going to think, okay, 5 times 1 is 5, 6 times 3 is 18. Nothing is in common between 5 and 18, so that is my answer. And last but not least, now we have negatives, mixed numbers, and division. So put all that together. Take one step at a time, though. Let's change our mixed number 4 2/3 to improper. You should get 14 over 3 times negative, oops, wait, I don't want to do that. The reason why I don't want to do that is because I want to change this to improper first and then take the reciprocal. So I'm going to back up. I'm actually going to erase that, and I'm going to rewrite it as division first, because a common mistake happens there with a lot of people. I'm going to rewrite that as division, and then it's negative 28 over 9. A mistake that often happens is a lot of people will write 4/3 times, and then they'll just change this and put negative 28 over 9 right there when they took that as an improper, and would forget to flip that. So take one step at a time. Change to improper, and then change it to multiplication. Okay, so this here is a no-no. Don't do that. So now let's flip that, change it to multiplication. Take the reciprocal or the multiplicative inverse. I'm going to do some reducing here, some cross-canceling. 14 and 28, they both have something in common, which is 14. 14 goes into 14 once. 14 goes into 28 twice. 3 and 9 have something in common. 3 goes into 3 once. 3 goes into negative 9, negative 3 times. So I'm going to rewrite my reduced fractions. 1 times negative 3 is negative 3, over 1 times 2 is 2, which then gives us negative 1 and 1/2. So this has been your lesson on multiplying and dividing rational numbers. Here I have 6 problems for you. I want you to take some time and do. The last 3 I am writing in the division symbols right now. I'm going to read the problems for you just so then that way you understand what they are. Negative 6/7 times 2/7, negative 5/12 times 3 1/9, negative 6 2/3 times negative 1/2. Next we have 6/11 divided by negative 4/5, negative 5/8 divided by negative 4, and negative 10 3/5 divided by negative 2 2/5. Please, please, please take some time, complete these 6 problems, bring them tomorrow to class. Thank you very much. Have a great evening.